guys, this is the final exam review over section 3, which is on the third test over graphing logs and exponentials. All right, we're going to go ahead and dive right into this. So it says, first question here, we want to find the end behavior, domain, and range of the following. All right, so the first four questions, or first four, have actual graphs for us, which does make it a lot easier. Remember, the biggest key in this unit, and I'll just write it to the top as a reminder, is understanding some of the differences with logs and exponentials. So when you're dealing with an exponential, all right, the first thing for you to remember is that you have a horizontal asymptote. You have a horizontal asymptote, and it's going to come from your y's. Right, the horizontal asymptote comes from your y's. Okay, on the flip side of that, when you have a log, you have a vertical asymptote. Right, remember L is very vertical, it's a very vertical letter, so log, vertical asymptote, and it's going to come from your x's. All right, and we'll use that some as we go. In this first section, you don't necessarily need it, but it's good for us to talk about it as you see it. So this graph is an exponential, right? I know it's an exponential because it has a horizontal asymptote. All right, so to find domain, I'm looking at left and right. So will my graph ever stop going left? The answer is no, so it goes to negative infinity. It will also never stop going to the right, so that's positive infinity. All right, because of the horizontal asymptote, though, I do have a restricted range, bottom to top. So my graph does have a floor here. There's a restriction on the bottom of it. So that floor is at positive 2. I'm not allowed to touch it, so I can't put a bracket. I put a parentheses here because I'm not allowed to touch positive 2. And then there's no ceiling here, so I can go all the way to positive infinity. Okay, to write out end behavior, remember the stuff that goes with x's is just going to come from your domain, so you can just list that out in any order you want. All right, for f of x, which is just your y, you're going to match up your range values to their corresponding domain values, right? So I need to have a 2 and a positive infinity here. It just has to know where I match up. I just have to know where to match it up. All right, so the first one, as x goes to negative infinity, that is left. So that's right here. As I go to the left side of this graph, I'm going up. So up is going to be represented by a positive infinity. All right, and then for this next one, as I go to positive infinity, so as I go right on my x, I'm hitting this floor at positive 2. So these four values should be these four values. You just have to match them up correctly. Okay, moving on to the second one. Okay, this is a log. All right, I know it's a log because it has a vertical asymptote. All right, and on a log, you're going to be restricted in your domain, left and right. It's going to have a wall. It's going to have walls. So for this one, you have a wall on the left. So that means as I go left, which always comes first, I'm going to hit a wall at positive 2. Once again, can't touch it, so it's a parentheses or parenthesis. As I move to the right, it goes on to infinity. There's no wall there, so I'm going to go to positive infinity on the right. Okay, my range up and down. There's going to be no restriction for logs going up and down. I can go down forever right here, and I'll slowly go up together, or slowly go up forever on the right. So that's going to be negative infinity to positive infinity. Okay, end behavior, same deal. We'll just put them in order. It doesn't really matter for your x's. So those are my two domain values. And now I have to match them up with my range values. All right, as x goes to 2, so as it goes left, it's going down, which is our negative infinity. And then as it goes right, it's going up forever, so that's going to be positive infinity. All right, third one, exponential, because of a horizontal asymptote. My range is going to be all real numbers, negative to positive infinity. There's nothing stopping it left or right. I am going to have a floor again, so something on the bottom will stop it. It'll be at negative 1. So floor, but no ceiling, so that's positive infinity. Go ahead and start your end behavior. Negative and positive, those are domain values. Match them up with range values. Okay, left, negative infinity is going to negative 1. Right, up here, is going up forever. So that's positive infinity. And there you go for number 3. All right, finally for the last one, another log, because I have a vertical asymptote. Okay, domain is going to have a left wall again at -1 right here. We're just going to go forever to the right. Positive infinity. Range is not going to be stopped. I can go down forever and up forever. In behavior. Alright, as I go to this -1, I'm going up. So I'm going to positive infinity. As I go to the right forever down here, I'm going down to negative infinity. Alright, so that's your in behavior, domain, and range for graph. Shouldn't be too bad. Alright, now for just the equations, this is where you have to kind of visualize and draw a sketch here for these bottom 4. Alright, so this is an exponential function. Alright, so we said up top, we know exponentials have a horizontal asymptote. That horizontal asymptote is going to come from the y area, which just means from the back, -8. So this graph is going to look something, I'll put it up here just roughly, it's going to have an asymptote at -8, so down here. And then the key decision here is this exponential growth or exponential decay. And for us, this is exponential growth because our base right here, our base is greater than 1. So it's going to be something like this. Doesn't really matter how perfect it is. All you have to know is that there's an asymptote at the bottom. All right, and then you're working your way up. All right, domain, left to right. It's not going to be stop going left, not going to be stop going right. Range, you have a floor here at -8. And then you have no ceiling, so you're going up forever. And I'm doing that the same way I did the first 4 based on this little sketch I made. Okay, in behavior. Just go ahead and get it set up with your domain values and then match them up. As you go left, you're going to this -8. As you go right, you're going up forever. Okay, for this next log function. Alright, for the log, rough sketch. Key thing, I have a vertical asymptote here. It comes from my x's, and remember, x's lie. So it says +8, but it's really -8. So you have this asymptote on the left. Alright, the normal log function is going to kind of look like it's going up. The only time that changes is if there's a negative in front. That's just what you have to remember with logs. So for this one, you're going to have something that looks like this, kind of like you had up here above. And the one right above it. Alright, it's going to look something similar to that. Doesn't have to be perfect. You just have to know where that wall is and whether it's kind of increasing or decreasing. This would be called increasing. Alright, domain. You have a wall at -8 on the left, but there's nothing on the right. Okay, range is going to be, you can go down forever or up forever. Negative to positive infinity. For your in behavior here, set up with your domain. Alright, -8. When I get close to this left wall, I'm going down, so that's negative infinity. And then when I go to positive infinity, I'm also going to positive infinity, which is right and up. Alright, moving on to the third one. This is another exponential. You're going to have in this case, you're going to have a horizontal asymptote at +5, so it's going to be up here. And this is an example of exponential decay. Alright, I know that because my base, this 0.4, is between 0 and 1. So it's going to look something like this. I'm decreasing here. Alright, that will affect your end behavior. Domain and range won't change a ton because of that. Domain is going to be negative to positive infinity because I can go forever left and right. My floor is going to be at +5 and I have no ceiling there. Okay, in behavior, as x approaches negative infinity and as x approaches positive infinity, my domain values need to find the range values they pair up with. Alright, as I go to negative infinity, as I go left, I'm going up, which is positive infinity. And as I go right, I'm coming to this 5, which is my floor. last one, log. Again, so I'm going to have vertical asymptote right here at -5 because it's lying to me. So -5 here. All right, in this case, there is a negative out in front, which means I reflect over the x. Okay, so I know that might seem a little tricky. Essentially, you're just taking this and imagine me flipping it over this x-axis. So it's actually going to look like some kind of decay here. It's going to be going down like that. Something similar there. All right, domain, you have a left wall at -5, but you have nothing on the right, so it's positive infinity. Range is not going to be restricted for log. I've seen that a lot by now. Okay, as you go to -5, and as x goes to positive infinity, once again, it's just your domain values. You got to pair them up with the correct range values. All right, as you go to -5, you're going up. So as I go to this left wall, I'm going up. As I go to the right, I'm going down. There we go. All right, that's domain and range and in behavior for just getting an actual equation of a function. All right, number 2, this follows right along with the stuff we talked about at the beginning. Find the asymptote for the following function. All right, this is an exponential. Exponential is horizontal asymptote, and it comes from the y, which means I'm going to get it from where I talk about my y's, my up and down. It's going to be this -3. And remember, y's tell us the truth. So my asymptote is just at -3. Y is equal to -3. For number 3, you have a log. Log, vertical asymptote, it comes from the x, and x is lie. So I come inside where my x's are right here. This negative, or this +7 is really saying -7. So it's going to be x is equal to -7. Okay, over to the back. Describe the transformation of the parent function 5 to the x onto, and you have this function with these different transformations. All right, let's just go through and talk about each one. First, we'll start in the front. You have the 7. 7, because it's greater than 1, it's going to be a vertical stretch of 7. So that's the 7 there. Get where you can see it. Okay, 5 is just a base. Remember, 5 is not a transformation. It's just a base. Okay, then we'll move here. This x plus 3. It's in the x's, so it's lying to us. So really, we're going left 3 here. And then this positive 1 is telling us the truth. We're going down 1 with that one. All right, so the only answer that has that, A and B have horizontal. That's not right. C has a horizontal compression or vertical compression, which is not right. So D is my only logical answer there. All right, number 5, describe the transformation of the parent function. So doing the same thing again here. So this 5 in front is again a vertical stretch of 5 in this case. All right, and then remember, because I have this negative out front, I need to remove that negative, which means I'm going to get a positive x minus 4. So really what's happening on the inside after that log looks like that. This negative is a reflection over the y-axis, and this minus 4 is lying to us, so it is actually a right 4. Okay, so your answer here, you have a vertical stretch of 5, so that's going to get us C and D. We're going to reflect over y, and you're going to go right 4, so that's going to be C. Okay, last one, number 6. Use the graph below to determine the transform function here. All right, first thing is this asymptote. So anytime you get a question like this, identify your asymptote first. Okay, so this is a log. So we'll write this out again, which means I'm going to have a vertical asymptote. That's how I know. And it's going to come from my x's. That's the key thing for this one. So this vertical asymptote at x is equal to -2 is going to come from my x's. And remember, in the equation, x's lie. So it looks like -2, but it's really going to be at x plus 2. So what that means is that in parentheses next to ln, I've got to have an x plus 2. So see what that does for me. It eliminates 4 of the 6 answers. You got to realize what we talked about at the beginning. The only difference in these 2 answer choices is that this one has no negative, this one does. Remember that negative means there's a reflection over the x. Okay, so a typical log function would work its way up, but since this was working its way down, we know there's a reflection, so this one would actually be f. All right, there is the video of that review.